Voyager 2's old data just solved a 40-year mystery about Uranus. Back in 1986, a spacecraft flew past Uranus and recorded something that made absolutely no sense. The readings were so extreme, so far beyond what anyone expected, that scientists spent the next 40 years unable to explain them. Now, using data that has been sitting untouched for decades, researchers think they have finally cracked the mystery. And what they found suggests Uranus might be a far stranger, far more violent planet than anyone ever gave it credit for. By the end of this video, you're going to understand exactly what Voyager 2 stumbled into almost 40 years ago, and why scientists say this planet deserves a second visit. Let's go back to the beginning, because this story starts with one of the most ambitious space missions ever attempted. Voyager 2 launched in 1977, just 2 weeks before its twin, Voyager 1. While Voyager 1 took a faster route out toward Jupiter and Saturn, Voyager 2 was given a different job. It was sent on what scientists called the Grand Tour, a rare planetary alignment that only happens once every 176 years, allowing a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune all on one continuous trajectory. No spacecraft before or since has ever pulled off anything like it. On January 24th, 1986, Voyager 2 became the first, and to this day, the only spacecraft to ever fly past Uranus up close. It was a brief encounter, just a matter of hours, but the instruments on board captured an enormous amount of data as the probe swept past the ice giant and its rings and moons. Among everything it measured, one particular reading stood out immediately to scientists back on Earth, and it was not a good kind of surprise. Voyager 2's instruments detected an electron radiation belt around Uranus that was far more intense than anyone had predicted it should be. Radiation belts are regions where a planet's magnetic field traps charged particles, similar to Earth's own Van Allen belts. Based on everything scientists understood about Uranus at the time, its radiation belts should have been relatively weak and unremarkable. Instead, the numbers coming back from Voyager 2 showed energy levels that simply did not match any model anyone had built. For nearly 4 decades, this discrepancy sat there as an unsolved puzzle in planetary science. Researchers proposed different explanations over the years, but nothing quite fit. Uranus is a strange planet to begin with, tilted almost completely on its side, with a magnetic field that is lopsided and offset from its center in ways no other planet in the solar system displays. But even accounting for all of that oddity, the radiation levels Voyager 2 recorded seemed impossible to fully explain using the science available at the time. If that thought just caught your attention, go ahead and hit that like button right now and make sure you are subscribed, because the explanation scientists just found is even stranger than the original mystery. The breakthrough did not come from a new mission or a new spacecraft. It came from scientists at the Southwest Research Institute going back and re-examining the old Voyager 2 data with knowledge that simply did not exist in 1986. Dr. Robert Allen, who led this new research, explained that science has advanced enormously since that flyby, and his team decided to take a comparative approach, lining up the decades-old Uranus data against everything researchers have since learned by studying Earth's own radiation belts up close. What they found points to space weather as the missing piece of the puzzle. The researchers now believe Voyager 2 arrived at Uranus during a rare and violent event in the solar wind, something called a co-rotating interaction region. This is essentially a large-scale disturbance in the stream of charged particles flowing outward from the Sun, capable of dramatically supercharging a planet's radiation belts when it collides with them at just the right moment. Here is where the story gets genuinely strange. According to the data, this event appears to have triggered some of the most intense high-frequency waves ever detected during Voyager 2's entire mission. For decades, scientists believed waves like these would actually work against radiation buildup, scattering energetic electrons and causing them to fall harmlessly into a planet's atmosphere. But more recent research, including direct observations at Earth, has revealed the opposite can also happen. Under the right conditions, these same waves can accelerate electrons instead, injecting even more energy into a planet's radiation belts rather than draining it away. Dr. Sarah Vines, a co-author on this new study, pointed to a real example that helped confirm the theory. In 2019, Earth experienced a similar event, one that caused a massive acceleration of radiation belt electrons here on our own planet. If a comparable mechanism struck Uranus back in 1986, it would explain exactly why Voyager 2's instruments recorded such an unexpected surge of energy during its brief flyby window. Think about what this actually means. For nearly 40 years, scientists assumed Uranus itself was simply behaving in some fundamentally unusual way, generating radiation levels through processes unique to the planet. Instead, the new research suggests something almost more unsettling. Voyager 2 may have simply gotten unlucky, Or lucky, depending on how you look at it, catching Uranus in the middle of a rare cosmic storm during the one and only close flyby humanity has ever attempted. If the spacecraft had arrived just days earlier or later, this entire radiation mystery might never have existed in the first place. That raises an uncomfortable question all on its own. Everything we currently know about Uranus, every model, every assumption, every textbook explanation is built on data gathered during a single brief pass by a single spacecraft. Decades ago, potentially during conditions that were not typical at all. Scientists have essentially been trying to understand an entire planet based on a handful of hours that may have caught it in an unusually chaotic moment. If that realization is starting to bother you a little, make sure you are subscribed right now, because the implications of this discovery go far beyond just solving an old mystery. This new explanation does more than just resolve a decades-old scientific headache. It fundamentally changes how researchers think about Uranus as a planet. If a single, passing space weather event was powerful enough to distort Voyager 2's readings this dramatically, then Uranus's magnetic environment may be far more dynamic and unpredictable than scientists ever assumed. Instead of a quiet, sluggish ice giant sitting at the edge of the solar system, Uranus might actually be a planet capable of dramatic, rapidly shifting radiation storms, something researchers have had almost no ability to study given that we have only ever visited it once. And this is not just a Uranus problem either. According to the researchers, the same mechanism could potentially apply to Neptune as well, another ice giant that Voyager 2 also visited briefly, and one that shares many of the same magnetic oddities as Uranus. If space weather events like this are common throughout the outer solar system, then our entire understanding of these distant ice giants may be built on similarly incomplete snapshots. Dr. Allen was direct about what this means going forward. He said the findings give researchers one more reason to send a dedicated mission back to Uranus, something NASA and the broader scientific community have been pushing for in recent years. A return mission would not just fly past briefly the way Voyager 2 did. It could actually stay in orbit around Uranus for an extended period, observing the planet's magnetic field and radiation belts over months or years instead of just a few fleeting hours, finally. Giving scientists a real picture of how this planet actually behaves under normal conditions versus rare, chaotic ones. There is something almost poetic about how this discovery came together. Nobody launched a new spacecraft to solve this mystery. Nobody sent fresh instruments out to Uranus. Scientists simply went back and looked at data that had been sitting quietly for nearly 40 years, and by combining it with everything humanity has since learned by studying our own planet's radiation belts, they finally understood what Voyager 2 had actually flown into all those decades ago. It is a reminder that some of the biggest discoveries in space science do not always come from new missions launching into the unknown. Sometimes they come from returning to old data with fresh eyes and new knowledge, finding answers that were sitting there all along, waiting for scientists to develop the tools needed to actually understand them. Voyager 2 is long gone from Uranus now, having sailed onto Neptune before eventually crossing into interstellar space alongside its twin. It will never fly past that mysterious ice giant again. But the brief window it captured back in 1986, once dismissed as simply confusing, has now become one of the most valuable pieces of data we have about how violent and unpredictable conditions around Uranus can actually get. So the next time someone tells you Uranus is just a quiet, boring ice giant that nobody bothers studying, you will know the real story is far more interesting than that. This is a planet that may have shown us its true chaotic nature for just a few hours in 1986, caught in the middle of a cosmic storm nobody even realized was happening at the time. And now that scientists finally understand what they were looking at, the case for sending a dedicated mission back to Uranus has never been stronger. If you want to be here the moment NASA finally commits to a real return mission to Uranus, make sure you hit subscribe before you go, because after 40 years, this planet may finally be about to get the closer look it deserves.